Okay, so lesson 2.4, day 1. This section is called zeros of a polynomial function. So our goal for today is I can find zeros of polynomial functions using a graphing calculator. So you will need a graphing calculator for this lesson. So if you don't have a graphing calculator out, please get out your graphing calculator. You can pause the video to go grab it. TI-83, TI-84 is what I'll be using, and you should be using too. Okay. So the opener does not require a calculator. You can go ahead and pause the video and do the opener. All right, so to check your answer here, it says given that x plus 1 is a factor that completely and find all the zeros. So I'm actually going to start off by writing my answer. F of x equals x plus 1 times, and then I know I have to get my other factors. So to do that, I'm going to use the method of synthetic division. I don't know why I paused so long there. Remember, C here is -1, so I'm going to use synthetic division, and then I'm going to put my coefficients of my polynomial here, and if I skip over a term, 0 is a placeholder. 1, 4, -7, -10. Drop the 1, multiply, that's -1. Add, that's 3, multiply, that's -3, -10, 10, 0. Remember, if it says that it is a factor and you don't get 0 there, you made a mistake. That's the only reason why that happened. Okay, so now I have the factor of this was a cubic function, so this is a square and this is an x. So now I have x squared, is it plus 3x? Yes, plus 3x minus 10. And now I want to factor this completely. It's not factored completely because this isn't factored yet. So I'll get my final answer. F of x equals x plus 1 times, two numbers that multiply to give me -10 and add to give me 3 are x plus 5 and x minus 2. All right, so that is my function completely factored. Don't forget f of x equals. Don't forget the factor of x plus 1. It also says here, find all of the zeros. Find all of the zeros. Notice I didn't give you any zeros, so you would have to, there's no other option other than finding all of them. X equals -1, x equals -5, x equals 2. And there are your zeros. Okay, so what we're doing today is very similar, except for the fact that I'm not going to give you a factor or a zero. You're going to have to use your graphing calculator to find one. And then once you have that 1, 0, and sometimes 2, once you have that, then you can do what we were just doing here. Okay, so recall a polynomial function of degree n can have at most n real zeros. These real zeros are either rational or irrational. We'll be using our graphing calculator to find a real zero. Our calculator won't find imaginary zeros, but we're going to use our graphing calculator to find the real zeros so that we can find the additional zeros. So we're going to end up finding all of them, but we're going to use our calculator to find the real one first. So state the maximum number of real solutions of this polynomial. So if you look, it's a third degree polynomial, so I'm going to have a maximum of 3. Now remember, there could be two or one zeros, real zeros. There actually can't be 2. There has to be either 3 or 1, but I'll explain that later. But we're going to use our graphing calculator to find any real zeros right now. So whenever I'm graphing, I go to y equals. I'm going to type this in. So x to the third power, plus 2x squared minus 131x minus 132. And then I'm going to go ahead and hit zoom standard, which is zoom 6, to get the normal -10 to 10, -10 to 10 graphing paper. Okay, so clearly you cannot see the whole cubic function, but I don't need to see the whole cubic function because I see a 0. I see a 0. You can't see where I'm pointing right now, can you? No. I see a 0, what looks to be at -1. So it looks to me that one of the zeros is x equals -1. Now, I could use the zero function of my calculator to make sure that it's -1, but I could also use synthetic division to check to see if -1 is a zero. Okay, so -1, and I'm going to do 1, 2, -131, -132. Drop the 1, multiply that's -1, add that's 1, multiply that's -1, add that's 1, -32, multiply that's positive 132, add that's 0. Okay, so one of the zeros is -1, clearly. All right, now notice it says write in factored form with real zeros, or sorry, with real factors. So I'm going to end up have to factor this completely. So I'm going to go ahead and see what I have left over right now. I have x squared plus x minus 132. And I'm going to factor this and find the zeros first before I move out of this problem here. Okay, so this needs to be factored. So I'm looking for two numbers that multiply to give me -132 and add to give me 1. So if you don't know your factors of 132, you can use your calculator to help you. So 132 divided by, and I'm going to do a big number here, I'm going to do 12. Oh, and 12 goes in there 11 times. So 12, 11 has to multiply to give me negative, so 1's negative, and it has to add to give me 1, so I'm going to make the 11 negative. Divided by my lead coefficient, so this factors to x plus 12 times x minus 11. So now I can get my other two zeros. I have 3 in total. I have this one right here, x equals 1, x equals -12, and x equals 11. So one thing that I noticed on your algebra review quiz, some of you are writing this. There's no commas in equations. This is an equal sign right there. So you cannot do this. Please don't do it, because on the AP test, you would get marked off. Okay, write in factored form, f of x equals. All right, so remember, -1 is a 0, so that means x plus 1 is a factor. And then here are my other two factors, x plus 12, x minus 11. And there's my f of x in factored form with real factors. Okay, so as you can see, it's pretty simple, right? Oh, another thing that I wanted to point out, let me hit the graph again, is that sometimes zeros repeat. Like -1 might have been a 0 twice. But I know it's not a repeated 0 here because the degree is odd because it's crossing. So I could check because maybe it if it crosses over, the degree is odd, so maybe it repeats 3 times. But if it's even, I definitely want to check it because it's definitely repeating. So if there was a bounce there instead. Okay, let's move on to the next one here. Given this quartic function, complete the following. State the maximum number of real solutions, 4th degree polynomial. So I could possibly have 4 solutions here. Find any real zeros using your graphing calculator. So y equals, I'm going to go ahead and clear this out. Make sure you clear and not write over it. It gets a little weird if you try writing over it. X to the 4th plus 3x cubed minus 19x squared plus 27x. Just be very careful when you're typing too so you don't miss something. Minus 252 graph. Notice I can just hit graph now because it's already set up for the -10 to 10. -10 to 10. Okay, so it looks like I can see 2 zeros right now. So the one on the left looks like it's at -1, -2, -3, -4, -5, -6, -7. X equals -7. And the other one, x equals 4. So I have 2 zeros so far that are real. Okay, so now what I want to do is I want to find the other 2 zeros. In order to do that, I'm going to use synthetic division. I can start with the -7 or the 4. It does not matter. I'm going to start with the -7. So I have 1, 3, -19, 27, -252. All right, I'm going to drop that 1, multiply it's -7, add that's -4, multiply that's 28, add, that's 9, multiply, that's 9, 18, 27, 36, 45, 63, negative 63, add, it's a negative number, and then 6, 2, 3, 7, so that's 36. I could also use this calculator right next to me. And then negative 7 times 36, I could use the calculator next to me, or I can do it off to the side. 2, carry the 4, 21 plus 4 is 25. And it's supposed to be 252, so I'm glad that it is, right? That means that negative 7 is a 0. Okay, so now I need to use the 0 of negative 4. Please remember that you are going to continue off of your new polynomial. This was a 4th degree polynomial here. This is a 3rd degree polynomial here. And we're going to bring it down to a 2nd degree polynomial. All right, so now I'm going to use 4. I'll drop the 1 again. Multiply 1 times 4 is 4. Add, that's 0. Multiply, that's 0. Add, that's 9. Multiply, that's 36. Add, that's 0. Okay, so I'm going to see what I'm left with. I'm left with x squared plus 9. This is x squared, this is x, and that's my constant. Okay, so I need to solve this now. So I'm going to set it equal to 0 and solve. This is a quadratic with just a square, an x squared. There's not an x squared and an x, so I can solve by square rooting. First thing I'm going to do is subtract 9 from both sides. And now I'm going to square root to solve. Remember, if you're square rooting to solve, you have to account for the positive and negative answer. So my other two zeros, x equals positive and negative. And then I need the square root of negative 9. Remember, there's going to be I in your answer. You're left with root 9, but we know the square root of 9, it's 3. So plus or minus 3i. And there's my 4 solutions. Negative 7, 4, positive 3i, and negative 3i. All right, write f of x in factored form with real factors. So I have f of x equals x plus 7 times x minus 4. That comes from this, my two zeros here. Now, people accidentally try to use their zeros, and they'll say x plus 3i and x minus 3i. It says real factors. So you're going to use the x squared plus 9 as your third factor, which is not factorable. So that's why we said real factors, to know to use that and not x plus 3i and x minus 3i. Okay, moving on. Another example. Y equals x to the 4th minus, make sure you use the minus, 2x cubed. Just so much easier just to retype it in, but I don't know why. Plus, delete that, 8x squared minus 14. Oh, see, clear. X squared. Oh, Lord. Start over. That's what I do. That's when I see. I just proved to you that retyping it is just easier. Okay, so I have x to the 4th power minus 2x cubed plus 8x squared minus 14x plus 7. Okay. Graph. All right, so going back to this, I'm going to have possibly 4 real solutions here. Notice in this one, I didn't have 4 real solutions. I had 4 solutions, 2 real, 2 imaginaries. Imaginaries always come in pairs also. Okay. So find any real zeros using your graphing calculator. That's what I'm working on now. And I can see that I have a 0. It looks like it's at 1. And notice it's bouncing there. So I have a feeling it might be a repeated 0. Okay, so I'm going to, and plus because I don't see any more real zeros, I could expand this to see if I, maybe there's one at 20. But I'm assuming that, no, I'm assuming, I know that it's a repeated 0. Okay, so 1. Coefficients 1, negative 2, 8, negative 14, and 7. Drop your 1. Multiply, that's 1. Add, that's negative 1. multiply that's negative 1, add its 7, multiply its 7, add its negative 7, multiply its negative 7, add its 0. All right, so repeated 0, so I'm going to do it again now. I'm going to do 1 again. Drop this 1, multiply that's 1, add that 0, multiply that 0, add that 7, multiply that 7, add that's 0. So now I'm left with x squared plus 7. So when you have a repeated 0, you do not have to write it twice. This is just repeated. And no, you don't have to write that it's repeated. I'm just writing it. You'll see why I'm writing it, to remind myself. Okay, now I'm going to find my other two zeros by setting this factor equal to 0 and solving. Now this is a quadratic that's not factorable, but it is solvable. I'm going to subtract 7 from both sides. And now I can square root to solve. I don't know why I'm picking terrible colors right now. Here we go. That you wouldn't be able to see. Okay, so I'm going to get my other two solutions. X equals plus or minus. It's the square root of a negative number, so I know I is going to be my answer. And then I have root 7, so I have to simplify root 7, which is not simplifiable. So I'm going to leave it as I root 7, positive and negative. So you have one real solution that repeats, two imaginary solutions. All right, now I'm going to write f of x in factored form. F of x equals, I had x minus 1, and then I had x minus 1 again, so I'm going to say x minus 1 squared. And then my other factor is x squared plus 7, and that's not factorable, so I'm going to leave it like that. Okay, a couple more left here. Y equals, clear, can't help myself, x to the 4th, oops, I keep hitting the wrong buttons, x to the 4th minus 4x cubed minus 4x squared plus 16x minus 105. Go ahead and get graph. State the maximum number of real solutions. I'm going to have at most 4 real solutions. All right, looking at my calculator, I can see 2 of my 4 solutions right now. So the one on the left is x equals -3. The one on the right is x equals 5. All right, so now I'm going to do synthetic division. It doesn't matter which one I do first. I just have to do both. So I'm going to start with -3. And I have 1, -4, -4, 16, -105. I'm going to drop this 1 here. I'm going to multiply. That's -3. I'm going to add. That's -7. I'm going to multiply. That's 21. I'm going to add. That's 17. I'm going to multiply 17 times 3. That's 60 minus 9 is 51. So -51. I'm going to add these two, negative, and then that's 41 minus 6 is 35. And I'm going to multiply, and that's positive 105, 0. Once again, there's a calculator right there. The numbers do get big sometime, but there's a calculator right there. Okay, now I'm going to do synthetic division with this 5 right here. So I'm going to drop my 1, multiply, that's 5. Add, that's -2. Multiply, that's -10. Add, that's 7. Multiply, that's 35. Add, that's 0. All right, so now I have x squared minus 2x plus 7. All right, so now I need to find my other zeros using this. So I'm going to set it equal to 0. I'm going to say, okay, I need to factor this. So I look for a GCF. There is no GCF. Then I think about factoring, and I say I need 2 numbers that multiply to give me 7 and add to give me -2. And there are no 2 numbers that do that. So this is not factorable, but remember, that doesn't mean it's not solvable. I can still solve it, and I'm going to use the quadratic formula to solve it. So I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now I need to clean that up. So I have 2 plus or minus the square root of 4 minus 28 all over 2. And I have x equals 2 plus or minus the square root of negative 24 all over 2. Remember, I have to simplify this square root of negative 24 next. So I know I is going to be in my answer. That's not a wonder here. So I'm going to put root negative 1 because that's going to happen. But then I know 4 goes in there 6 times. And this is I, and this is 2. So 2I root 6. So I have 2 plus or minus 2I root 6 all over 2. And then last but not least, both of those are divisible by 2. So I have to divide this by 2. That's 1. So I have x equals 1 plus or minus. Divide this by 2. That's I root 6. So there are my 4 answers. 2 are real, 2 are imaginary. Write f of x in factored form with real factors. F of x equals x plus 3, since negative 3 is a 0. X minus 5, since 5 is a 0. And then remember, this was not factorable, so I'm not going to write this into weird factors here. I'm going to write x squared minus 2x plus 7. And that's it. Okay, the very last one. Notice they're all a little bit different things happening here. First one we did, it was like super basic. The second one we did like, ooh, we got imaginaries. The third one we did was like, ooh, you got imaginaries, but also repeated. The fourth one was like, guess what? You got to use the quadratic formula. Let's see what the fifth one's going to give us. Y equals clear 3x to the third power, get out of there, plus 16x squared minus 167x plus 220 graph. Okay, ooh. Anything else? No. Okay, so when I look at this one, I see that the first 0, the one on the left, it looks like it's at 1 point something. So I know it's a decimal and I can't guess where it is. Yes, I could use my 0 feature, but I say, okay, well, I definitely see that there's one at 1, 2, 3, 4. I definitely see that there's one at x equals 4. So I'm going to see if I can just use that to get the other two. Okay, so this is going to have 3. And notice if I have three possible solutions and I know one of them is 4, that means there's 2 left. If there's 2 left, that means that if I use synthetic division, if I have 1, 0, and I'm starting with a cubic, that means I'm going to get it down to a quadratic. And I know how to solve any quadratic there ever can be given to me. So I will be able to find the other 2 zeros. All right, so I'm going to start with 4 here as my C value that I'm dividing with. This is 3, 16, negative 167, and then 220. All right, numbers are kind of big, so if you need to use your calculator, you can. This is a 3 multiply, that's 12. Add, that's 28. Multiply, okay, so if that was 30, it'd be 120, but 120 minus 8 is 112. Yes. Okay, then this is going to be negative, and then that's 55. And then that's negative 220, which is 0. Look at, I did it. Okay, so now I have it down to remember this is a quadratic now. 3x squared plus 28x minus 55. All right, so now I have to try to factor this. Okay, now I have to try to factor this. So I'm going to set it equal to 0 and solve because I want to get my zeros first. 2 numbers that multiply to give me, so let me get out of the graph here, negative 55 times 3. No, I said negative 55 times 3, which is negative 165, and add to give me 28. All right, so I need factors of 165. So 165, I know 5 goes into it, so let's see what that is. 33 and 5, yes, right away, 33 and 5. I'll make my 5 negative, but don't forget divide by your lead coefficient of 3. So this one, the first one is simplifiable. That's 11 over 1. So that's going to become x plus 11. And my second factor is 3x minus 5. And now I can set each equal to 0 and solve, and I can get my other two zeros. X equals negative 11, and x equals positive 5/3. So now you can see that if I go back to my graph here, the first 0 that I can see with my eyes right there, it was 5/3, so I couldn't tell what it was. Also, if I change my window, if I hit window and I change my x minimum to negative 12 graph, you can see that there's the negative 11 that just popped up over there too. Right? Okay. F of x equals, all right, my factors. I have x minus 4. And then please don't write x plus 11 and x minus 5/3. X plus 11 is correct. But then it's 3x minus 5. Okay. All right, that's it for today. I basically showed you an example of every possible thing that can happen. So hopefully you know what to do each time.